So again, we got the y equals mx plus b. We got the slope, y-intercept. Right? Now here, okay, if for some chance you accidentally forget, you can switch these as long as your subscripts match up. Okay, here y2 minus y1, x2 minus x1. The 2 comes first. Okay, you could put the 1 first, but the 1 has to come first for both the y and the x. Okay, this is a 1. All right, so if you switch them, if you swap them around, that's okay. Just make sure it's consistent. Okay, there's another name for this that we might see. Okay, especially moving on to some more challenging things. Okay, this is also called the average rate of change. All right, that's something else that you might, it might be referred to. Okay, or just rate of change. You don't always have to say average. All right, so I'll give you guys a quick example. All right, so you're going to find, real quick, I'll give you some time on your own. I want you to find the slope of the line that passes through 3, 4, and I don't know, 5, and 5, 7. So take a minute, find the slope of the line that passes through 3, 4, and 5, 7. Oh, okay, so we got a 3/2 and a 2/3. So I'll be careful. So the numbers are right, but which one goes on top? Okay, so which values, what 2 values am I using for my y's? The 3 and the 5, or the 4 and the 7?
The 4 and the 7.
The 4 and the 7. Okay, so let's say by whatever chance.
1.
All right, so that's our xy, xy. So what I like to do is I like to label, right? So I'll say that this is x1 and y1, x2 and y2, right? If you want to put like little ones above it, right? Just so you have everything organized, okay? So let's say, for example, though, I mess up and I put the 4 first, right? So the y goes in the beginning, right? So I do 4 minus 7. Okay, so you're thinking to yourself, uh-oh, I'm going to get a negative, right? But if I put the 4 first in the numerator, what should go first in the denominator? Which number matches with that 4?
Definitions we went over, and so look at the link on the previous slide.
What coordinate? Okay, right. So good. We would write the 3 minus 5. Okay? So in the numerator, we get a negative 3. In the denominator, we get a negative 2. What happens when we divide 2 negative numbers?
It turns into a positive.
It turns into a positive. All right? So we have 3/2. All right? So just be careful if you had 2/3. That would be the, if we swapped our y and x-axis coordinates. Okay? Okay, so, right, if one thing I may ask you to do, okay, and one thing that you're going to be doing when you get, actually probably at the end of this year, and in AP Calculus is finding the equation of a line, right? So with something like this, we're halfway there. Now there's a few different ways, right? We can go back and we can use this, right? But I'm going to go over a somewhat simpler way. We have more than one way to show a linear equation, right? So this slope-intercept form is just one way. We also have something called point slope form. Okay, so obviously we need the slope. That's what defines a linear equation. But for point slope form, instead of just using the y-intercept like we did above, we're going to use a point. Okay, so we need three things. We need the slope, we need an x-coordinate, a y1, I'm sorry, x1, and a y-coordinate, y1. Right, so point slope form looks like this. Okay, does this look familiar from last year at all, or is this new to you guys?
It looks familiar.
Okay, you may not have used it a lot, but okay, as long as you've seen it before, that's good. Okay, so what we're going to do now All right, so what we're going to do is we're going to write an equation, a linear equation, for the above example. All right, so I have my 2 points, 3, 4, and 5, 7, and I have my slope. Right, slope was 3/2. So now, this is up to you. What point do you want to use? Do you want to use x1, y1, or x2, y2? I'll let you guys pick, whoever says something first.
X1, Y1.
All right, so let's use 3, 4. Okay, so I'm going to write it down just so we have it kind of organized, okay? So our m, we said, was 3/2, and my x1, y1, we said, is going to be 3, 4. All right, so with point slope form, this is an equation. I still need a y and an x in it, okay? So this is going to stay y, and this is going to stay x. You're not plugging anything in for those two values. Okay, we're just going to plug everything else in. So I'm going to have y minus my y1 is 4. Okay, equals my slope, 3/2, times x minus x1, which is 3. All right, this doesn't look very nice, right? We like it in slope-intercept form. So we're going to manipulate it a little bit. If I wanted to get this y by itself, right, I got to do what with this -4, -4, to move it to the other side?
Add it.
Inverse operation.
Right, we got to do the inverse operation, right? So we're going to +4. Before I do that, though, what can I do over here to make this look a little nicer?
Multiply.
Right, we can distribute, okay? So I'm going to keep the 4 over there for now, y minus 4. All right, well, this is simple. That's just going to be 3/2 x. Okay, now when we multiply this, right, this is 3 over 1. So 3/2 times -3 over 1 is going to get me -9/2. Okay, and then like we said, right, we're going to +4. Right, so our final equation, y equals 3/2 x. Now just be careful here. Okay, -9/2. If I changed 4, what would I have to change 4 to with a common denominator? What would 4 become to add the fractions together?
Eight over 2.
Good. So I'm going to change that to plus 8 halves. So negative 9 halves plus 8 halves is negative 1 half. All right, and we have our linear equation. Now, if you chose to do 5 and 7, okay, you'd end up with the same exact thing. The way the numbers would work out, okay, you'd still end up with that negative 1 half on the right side. Okay, any questions so far?
No.
Okay. All right, so sometimes they'll give you 2 points, okay, and then you do what we did. Sometimes what they'll say is they want you to find a line that is parallel or perpendicular. Okay, so for parallel and perpendicular, we're going to focus on the slopes. What do we know about the slopes of parallel lines? What should they be? Right, if I have 2 lines that never touch, right, they go in the same direction forever and ever. What do we know about their slopes?
Undefined?
Not undefined.
No, they have the same.
There we go.
The same slopes.
Okay, we say, right, they have the same slopes, or in math, they have equal slopes. That's real quick. What would it mean if I had an undefined slope? What would my line look like then? What kind of line would I have if my slope was undefined? Do we remember?
Is it like a straight line? Right?
Oh, they're all straight lines, yes.
No, but like
Like a
going up or
vertical?
down, or like
There we go. Yep, I think I heard somebody say vertical.
Vertical?
Okay, right? A vertical line has an undefined slope. Okay, good. Okay. Now, so that's pretty easy, right? Parallel lines have the same slope. So if this slope was, like we found before, 3 halves, oops, right? This one would also be 3 halves. Okay, now perpendicular slopes, there's a special relationship. Okay, and then there's 2 key words that we use to define perpendicular slopes. Do you remember what they are? Okay, we say that perpendicular slopes are opposite reciprocals. Okay, so those are the 2 key words. Right? Opposite means we change the sign. Reciprocal, what do we do for a reciprocal?
Flip it.
Right, so if it's a fraction, we flip it, right? So the mathematical way we write that okay, is m2 equals negative 1 over m1. All right, so if we're looking at numbers, right, so say I had before, right, 3 halves, a perpendicular, right, because that's positive, we change it to negative, right, and I flip it to 2/3. Okay, so those 2 would be perpendicular. If we drew those 2 out, what does it mean to be perpendicular? What happens at the intersection? It makes a what?
A right angle.
Good, right? 90 degrees, a right angle. Okay. What if my slope was just -4? Okay, so this always kind of throws a wrench in the system. If I just had -4, if I have a whole number, what could I always make that into a fraction? What can I always put it over?
1.
1, right? So the opposite reciprocal, we would change from negative to positive. Now you don't have to put the plus sign. I know what you mean if you don't put it. And then we would flip 1/4. Okay, so those would be perpendicular slopes. All right, so we'll end with one example. Misspelled that. Okay, so example, we're going to find the equation of the line perpendicular to y equals 1/2 x plus 3 that goes through the point 2, 2. All right, so the first thing that we need to do is find the slope. Okay, I'm going to call it the new slope, right? So m new. You could say m2, or you could just call it m. So what is my original slope? What is, for the original equation, what is the slope that I have?
-2.
Okay, so that's going to be our new slope, right? Because my old slope was 1/2. Okay, so my new m is -2. Good. And then we have our x1 and our y1, right? They give that to us. That's 2, 2. A lot of 2's here, but that's all right. So now we're going to use point slope form. I'll write it down so we have it. All right, and we're just going to plug in and then simplify. I have y minus 2, right? That's my y1, 2, equals -2. That's my slope. X minus 2 again. Okay, and then we're going to distribute. Okay, be careful. -2 times -2 is going to be +4. Right? And then I add add 2 to both sides. And we have the equation of our perpendicular line. All right, so if you graphed it out real quick. Okay, my original 1/2 x plus 3, so that would, maybe be, I'm just sketching it out. Let's be going like this. Okay, and then our new one is -2x plus 6, so it would come down like this, and you'd have your right angle there. Okay, any questions about that? All right, so again, I recorded this, so later this afternoon I'll be putting this lesson up on Google Classroom. Tomorrow you guys will have an assignment, okay? So that is your only responsibility. We will not be meeting on Google Classroom, on Google Meet. Excuse me. I will be here if you need extra help, okay? So, if you're doing some problems and you're stuck, right, between 10:30 and 11, I will be on the Google Meet, and you can pop by and say, hey, Mr. Murray, can we work through this? I'll say, sure. Okay. But you are not required to come to class tomorrow. Okay. Wednesday, we will meet again. All right. Is that clear? Everybody good?
Yeah.
Yes.
Yeah.
Okay. Thank you. All right. So check the Google Classroom. Again, I'm going to put up an assignment and today's lesson, and then we'll meet again on Wednesday. All right. So if you don't have any other questions, that's all I got for you today. All right. Enjoy the rest of your day. Good luck with the rest of your classes. I'll see you on Wednesday.
Thank you. You too.
Bye-bye. Thank you.
Bye.
Or Monday.